Welcome to my channel, IGCSE TV. Please subscribe, share the link, and comment. Today we are going to demonstrate how to convert hexadecimal numbers into denary numbers, right? We are going to show you how to convert hexadecimal numbers into denary numbers. So there are two methods that we can use to do this, right? The first one, we will have to convert the first one, we simply have to consider the numbers that we have. Let's say if it is 3A1, right? We convert 3 into binary, we convert A into binary, and then 1 into binary. Then we simply combine those binary numbers together to produce a 12-bit binary number. Then we convert that 12-bit binary number into a denary number, right? That's the first method. But there is another method where we can simply make use of the hexadecimal values. We simply raise 16 to the power of natural counting numbers. Let's say we are converting 3A1, so we raise 16 to the power 0, 16 to the power 1, and 16 to the power 2, and then we multiply those values by the numbers, by the hexadecimal values that we are given, and then we add after that. So those are the two ways which we can use to convert hexadecimal numbers back to denary numbers. All right, so stay with me. I'm going to show you right now how to do those methods. All right, so the question says convert 3A to decimal oblique to denary oblique decimal number. So the first method, we write 3 and then our A here. So in this symbol table, so we need to convert 3 to binary and then A to binary. Then we combine the binary numbers together. Then we convert that binary number into a denary number. So 3 is less than 15. So we can use 4-bit binary units to do that. So the 4-bit binary units are 2 to the power 0, 2 to the power 1, 2 to the power 2, and 2 to the power 3. Same applies here. A, remember, it's equivalent to 10, right? So again, we can represent this using a 4-bit binary. We can a 4-bit binary, 4-bit binary number which uses 4-bit binary units. So 2 to the power 0, 2 to the power 1, 2 to the power 2, and 2 to the power 3, like this. So now we need to consider all the binary units that, if added together, they will give us 3. So in this case, 8 is greater than 3, we switch off. 4 greater than 3, we switch off. 2 is less than 3, we switch on. 2 plus 1 to give us 3, 3 is equal to 3, we switch on. So we now have the value for 3, and then A is equal to 10. So 8 is less than 10, we switch on. 8 plus 4, 12, it will be greater than 10, we switch off. 8 plus 2 is 10, 10 is equal to 10, we switch on. 10 plus 1, 11, it will be greater than 10, we switch off. So now we have got the binary numbers for 3 and A, right? So we simply combine these binary numbers to come up with 0, 0, 1, 1, 1, 0, 1, 0. So we now have an 8-bit binary number. So for us to convert this 8-bit binary number to denary or decimal, we use 8-bit binary units, which are 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6, 2 to the power 7. And the approach again is the same. We consider all the binary units that are switched on, and then we add them. So in this case, we have got 32 plus 16 plus 8 plus 2. 32 plus 16 is 48. These two, they will give us 48, plus 8 plus 2 is what? 10. So 48 plus 10 is what? 58. So this is how we convert from hexadecimal into denary or decimal number using this first method. So this is 58. So I want to show you again how to convert the same. We only have two characters in our hexadecimal number, which is 3 and A. So therefore, we need to raise 16 to the power of 0 and 16 to the power of 1, right? So 16 to the power of 0 is 1, 16 to the power of 1 is just 16. So now we have our 16 here and our 1. Then we multiply 3 by 16, 3 by 16, and then a by what? 1. So a is equal to 10, like this. So we do 16 times 3 plus 1 times 10, like this. So 16 times 3, it's 6 times 3 is what? 18. 8 carry 1. 3 times 1, 3 plus 1 is what? 4. And then plus 1 times 10. 1 plus 10 is what? 1 times 10 is 10. So 48 plus 10 is equal to 58. So the answer is the same. So you can use the other method, and then the second method you use it to prove whether your answer is correct or not. So this is how we convert from hexadecimal into denary using this method. Maybe let us do another decimal number. So we need to raise 16 to the power 0, 16 to the power 1, and 16 to the power 2. So 16 to the power 0, 16 to the power 1, 16 to the power 2. So 16 to the power 0 is 1, 16 to the power 1 is just 16, and 16 to the power 2, it will give us 250, should be 256, right? Let me just confirm this with my phone. Let me just punch the numbers. 16 by 6, it will give us 16 by 16, 16 by 16 is 256, exactly, is correct. So 16 by 16 is 256. So the numbers that we have, the hexadecimal number that we have is 3A and C. So we multiply 256 by 3 plus 16 by 10 plus 1 times 13. C is 13 according to our table. So 256 by 3, 3 times 6 is 18, 8 carry 1, 3 times 4, 15, plus 3 times 6 said 18, 8 carry 1, 3 times 4, times 5, 15, plus 1, 16, 6 carry 1, 3 times 2, 6 plus 1, 7. 768 plus 60 times 10 is 160 plus 18, right? So we have 768 plus 173. Now let us add 3 plus 8, it will give us what? 11, right? That's 1 carry 1 here. 8 plus 6, it will give us 14. 4 carry 1, 2 plus 7, 9, 941. So this is how we convert using this method from hexadecimal to denary. So you can again use the other method, right? The other method is to first convert 3 into binary, A into binary, C into binary. Then you combine those binary numbers to come up with a 12-bit binary number. Then you write the corresponding binary units on top of that binary number. Then you consider all the units, right, that are switched on. Thank you for staying with me throughout the video. So that is how we convert hexadecimal numbers back to denary numbers, right? The process is very simple. We either use the conventional method that you all know, whereby we are supposed to first convert each and every character in our hexadecimal number to binary. Then we combine those binary numbers, right? And then after that we convert those binary numbers into a denary number by using the binary units, respective binary units. If we get an 8-bit binary number, then we need to use an 8-bit binary unit. If we get a 12-bit binary number, then we use a 12-bit binary unit. And again, there's another method that I demonstrated, right? So that one to me is quite easier. You simply have to consider the characters you have in your hexadecimal number. Let's say if you have got 4 characters in your hexadecimal number, you simply raise 16 to the power 0, 16 to the power 1, 16 to the power 2, 16 to the power 3. Then you get those values. You write your hexadecimal numbers just beneath as they are, right beneath the base 16 units, right? And then you multiply. Let's say in the previous example that I gave, it was 3AC. You multiply 3 times 256, which is as a result of 16 by 6. Then you add A times you add 16 by A, right? You add 16 by A, then you add 1 by C, then you get your answer. So it's as simple as that, but you can choose the one which is easier for you. Some they prefer the first one, but for me personally, I prefer the last method. It is very simple and straightforward. It doesn't have too much stages that you need to go through. So that is how we do that. Alright, thank you very much guys for staying with me. Please subscribe to my channel. If you've got any queries or anything that you want me to specifically do for you, you can comment using the comments below, and you can also contact me on my WhatsApp using the numbers appearing on your screen. And again, please follow me on my social media platforms, Facebook, LinkedIn. On Facebook I've got a profile and a page, so please follow me on those platforms. Again, I also post content there. So that is all for today. Thank you very much. Have a nice day.